So Meals on Wheels. So they've come to us to see if basically if we can optimize some of their routes. So they provide, as some of you probably know, 200 meals a day across 20 drivers. I believe there's 2 or 3 kitchens that they serve out of. And basically they serve meals. Oh, just a second, I've got an echo.
Okay, quick. Everybody take a screenshot. Yeah. Well, Rory, now that you're, oh, okay, yeah, we can talk later.
Yep.
All right. So where was I? Meals on Wheels, 200 meals a day, 20 drivers. Where was my train of thought there? Here, just a sec. Yeah, so Meals on Wheels, where's my train of thought there? Yeah, so they provide meals to those in need. Most of their demographics are the older population, basically people that can't provide meals for themselves. So basically, yeah, they want us to optimize some of their routes, and we can do that in ArcGIS Online. So what I've got here is I did a couple layers, one for kitchens and another for addresses. So this is just dummy data. I just went in, created some fake points all across Fredericton, and that would be the client. So that would be basically where they would be delivering meals. So it doesn't really look that great right now. So I'm just going to change a few things here.
Hi, Pierre.
So I just want to, yeah.
I cannot see your screen. Can you share your screen?
Geez. Sorry about that. Guess that's an important thing, isn't it? There, can you see my screen now?
Yep.
Okay. So here I've got, again, address locations, just quickly done up. So those would be the clients. So it doesn't really look that great. So what I want to do is to change the symbology. So you can do that again, as we saw last week, just this change style. And it's going to be a basic location. I don't have any other information in there. But like as we saw last week, we can get different types of we can change the here. I'm going to change that a little bit. Here, let's go green. We can change the symbology based on attributes within the layer. But since there's no information in these points, they're all going to look the same. And we can do the same thing with kitchens here. We'll change symbology. And if you have any questions, please ask. Done. So as you can see, we've got a kitchen down in on Sunset Drive. If you're familiar with the area, there's York Senior Home. We have a kitchen at the hospital and here at Greener Village. So basically those are going to be our start points for the routes. And basically we've got 20 drivers delivering meals to all these points here. So the way to do that, we'll start with the addresses. So we'll say perform analysis, use proximity, and then plan routes. So this is going to be the tool that we will use to find routes, the best routes for, to optimize those 20 drivers. So we're going to say we want to optimize for driving time. So there's different travel modes here, and it's basically the way you want to optimize. So if you want driving time, trucking time, walking time, there's a rural driving time here. And basically, it just optimizes based on whatever what you decide. So we're just going to say driving time for this one. The routes begins at stops. We're going to say the kitchens. Route ends, we'll just say return to start. So this one here, the maximum number of vehicles to routes, that one's you can't change this one for some reason. So we'll just skip to the next one. So we'll say number of stops per vehicle, we're going to say 10 because we have 20 drivers over 200 stops. And then we're going to say, you know, they're probably spending about 15 minutes at each stop. You know, we've heard that quite a few of the drivers know the clients quite well, and they kind of stick around to talk for a bit. And then here we can say limit the time, but we're not going to do that just because we know they're not going to hit the time limit. You know, these routes are going to be fairly quick. So I'm just going to show credits here, make sure it makes sense. And then you can hit run analysis. So now it's basically just running through, finding the routes. Might take a bit.
You might have mentioned this last week, but are there different routing algorithms, or is it primarily the same?
There probably is, but I think the main one that they use, I forget the name of it. Here, I'll see if I can find it. Yeah, so it's called Dijkstra's algorithm.
Okay, yeah.
So here, I'll write it out here. Dijkstra. So that one there. So there's a nice Wikipedia entry on it with a nice little diagram. Yeah, so there's a way of going by. If you want to learn about it, it's really interesting. It's basically going point by point and then doing a calculation based on which points it's connected to.
Yep.
Here they're number 3, they're going to 4, 6. I forget what the calculation is, but there is one. And then basically when it's done, then it finds the quickest path.
Yeah, it's basically a least cost routing. We use Dijkstra in network engineering as well, of course.
Oh, okay. Yeah. Yeah, so this one, this one's basically, you can just think of the nodes. Actually, I can go over that a bit. Basically, the nodes would be where your roads are connecting. So basically, in the most basic sense, it would be an intersection, right?
Right.
So now we've got all the routes. They're all color coded here. We can say, I'm not sure if we can change the colors. Yeah, no, I'm not going to bother with that. But here you can see they're all different color coded with the number of stops for each route. Some of them might be a bit hard to tell the difference here because you got different shades of purple and blue. But you'd be able to basically change the color and make it kind of look better. And each route, so if you click on a route, it'll give you the stop count, total time in minutes, total service time, which, you know, it's an obvious, it's a 10 times 15 minutes. Your total travel time, total kilometers or miles, and basically a start and end time. We didn't set the start and end time just because it's not really relevant for what we're doing right now. But if you want to do something where you had something more set, you know, if you were a business or something that, or you want to start at a certain time and end at a certain time, you can definitely set those parameters up. So one thing that if you're driving quite a lot around town, there's construction, and you can see some of these routes go right through some construction zones. So here, Regent Street, part of it's closed. So basically, that's not really helpful for us if we have to find detours. You know, if you have somebody out of town coming in, they're going to be, you know, frustrated going down Regent Street, not knowing where to go. So there's ways of mitigating that. So we can go perform the same analysis, but we can add barriers. So we'll say, go back here, use the same addresses, driving time, but here we're going to select a barrier layer. But before we do that, we need to add a barrier layer. So here I've got, I'm on the Fredericton open data portal. So I'll just go back here. So this is where the city of Fredericton hosts all their open data. Open data and GIS go hand in hand. Everywhere, you know, there's always a GIS component when you're going to these data viz competitions. So I'm just going to go over, I'm going to click on one here, and I want to see the full details. Why I want to do that is basically I can download, you know, I can download data and then upload it again on ArcGIS Online, but I find that a bit cumbersome. I like to do things quick. So basically what you can get, where is it? View data source. Oh, here we go. So if you go to view data source here, basically you can see all the services that are hosted within, so it's almost like an easier way of looking at for data. So those are all the services that are hosted on their open data portal. So I'm just going to look for construction. And then this is basically the Fredericton construction feature layer that they use to show on their the City of Fredericton website. So I'm just going to go on this layers here, and basically I'm going to copy this URL. And when I go to add data, I can say add layer from the web, and I can just copy and paste that right in there. So as you can see, now I've got the construction layer for the City of Fredericton. I'm just going to change my base map here, make it a little bit easier to see. That's not a good one. There we go, that's a little bit better. So here you can see there's a construction zone on Regent Street. It's currently shut down. So we'll use this layer as a barrier. So basically we're going to tell the ArcGIS Online, don't use these street segments. So back to my addresses, I'm going to go analysis, use proximity, plan routes. So same thing, driving time, but then here I'm going to say select barrier. And this is a line, so these are all lines. So I'm going to say a line barrier, Fredericton construction. And then basically I'm going to use the Meals on Wheels kitchen layer as my start points, return to stop, or return end stop. Then I'm going to go to, wait, why is this not? Okay, I'll say 20 for there, 10 here. Wait. Choose representing stops. That's fine. Driving time. Oh, I see why. So down here, I don't know why they do this, but by default, you got use current map extent here, and it's checked. So basically, right now, I don't have any Meals on Wheels kitchen features available, so you can't see them. So I'm just going to uncheck that, and this should work. Update now. Yeah, so maximum number of vehicles, it's updated, grayed out. I'm going to say maximum of 10 stops per vehicle. Same thing here, 15 minutes. I don't want to limit the time. And I'm just going to double check this. That's fine. So then I'm going to go run analysis. Oh, got to change the. So I'm just going to call that barriers. So we'll let that run for a bit. Yeah, so in a street network, it's really interesting when you get into the data component of a street network, because basically you've got when you have a road network that's usable in a routing analysis manner, basically it's made up of nodes and lines. Your nodes basically tell you. If you're looking at the backend database, it basically tells you where because each segment would have a node, and it basically tells you, if you're at a four-way intersection, it'll tell you, okay, I'm connected to nodes 2, 3, and 4, and so that's how it knows, how the road network's all connected to each other. Now I've got my new routes. That didn't really work as well as I intended, but here you can see, here's a good example, somewhat. It's we're not really using that accurate data. Some of these road segments would be open to traffic, but you can see here where the only way that it can find to go to these addresses here in Lincoln would be to go all the way down Lincoln Road and then take Nevers Road and then back on the highway. So it's basically avoiding these construction zones. So here there's paving done here not too long ago. Same as Wilsey Road here, a little bit of construction here. So it's basically avoiding these construction zones. So that's how you add barriers. Your barriers could be anything, Oh, right, yes, I haven't been keeping track of that. Hey, Joy, sorry about that. Yeah, so as I was saying, barriers can be anything. Construction's one of them. If you're looking at, when we have flooding in the spring, that could be another barrier. So it can be pretty much anything you want. If you want something to avoid an area completely, you just add a barrier. And it can be polygons, it can be a point or a line. It's basically no-go zones. So that's how you find your routes. Now, another question that they might have, Meals on Wheels provides those meals to older population. But some other questions that they could ask is, do we have enough do we have enough kitchens to, serve our population now and maybe even into the future, right? We have a growing older population. Basically, do we have enough capacity to meet those demands later on? And also, are my kitchens in the right spots, right? So there's different ways we can go about doing this. One would be looking at the area that's served by these kitchens. So basically what we can do is say, what area would be optimal for this kitchen, and this kitchen, and this kitchen, right? The one on the south side here at the hospital would serve, for the majority of the south side, and then these two would share the north side. But what does that look like, basically? So we can do that. We can say, we can go to perform analysis here, and basically use something that's called create drive time areas. So that's just going to create a polygon of basically where the areas that would be served by these kitchens. So I'm going to actually add a different layer here, since the Meals on Wheel kitchen one is not that. So to have that work the way I wanted to with the run analysis, I had to create 30 or 20, 30 different points for the kitchens. Basically, that's just the only way that you can get it to work, because every route is going to start at a kitchen, and the kitchen has to be distinct from each other. So basically, I don't want to create a drive time analysis for 30 different kitchens again. So I've got another layer here that I created. It's the same thing, but this one only has 3 points instead of like the other one that had 90 some points in it. So back to create drive time areas here. So in this one, same thing. So you get different measures here. You can say driving time, driving distance, walking time, walking distance. So I'm just going to say, I'm going to stick to driving distance in this case. And I'm just going to say 10 kilometers. I've already run this, and I know 10 kilometers is a good number. It encompasses pretty much all of the city of Fredericton, and it goes a little bit on the outskirts as well. So I'm going to say driving away from the facility. And then here I'm going to say split. So basically where two polygons are going to be coming close to each other. So let's say, between the Greener Village and the York Manor, you're going to have a split here. So there's different ways you can define those splits. You can say have a distinct split between the two. You can dissolve. Basically, it would become one polygon instead of two, or you can overlap. So basically you would have an overlap between the two, but you would still have two distinct areas in this case. So I'm going to split it just because I want to know which areas are, would be serviced by each of these kitchens.
Pierre,
Yeah,
quick question.
sure.
Can you do a shortest split line when you're dividing this based on like proximity to the kitchen?
Say that again.
A shortest split line, which would sort of, I know it in terms of electoral districts and anti-gerrymandering. The idea is you let a computer calculate the an electoral district based on the shortest split line algorithm.
Not quite sure. I don't think I've never looked into that, so I would be able to tell you. Sorry.
Okay. Oh,
Yeah.
okay.
Yeah, I've never, I don't know. I'd be interested in learning about it though.
Yeah. Okay. I'll try to look into this as well. It just caught my attention and
Yeah.
something I have some familiarity with.
Right. So this one's pretty much done. I'm just going to say run analysis. We'll see what the results are. Just going to check, see if anybody else needs to be brought in. Nope. Right, so there we go. So that's, I'm just going to change the, symbology here a bit. Choose. They only give gradients. They don't give me the choice of classified data. It's a little bit hard to see. Here, what if I do it this way? I guess, well, you can see, so you'll be able to see here the north side, so it's split here. So basically these are the areas that would be serviced. So this one here would be the Greener Village. This one here would be the hospital, and then this one here would be York Manor on the north side. So that's great. You know, I can see the area, but that doesn't really tell me much about, you know, who's living there, who's going to be living there in 10 years. So as we did last week, we can go and add some data enrichment. So in this case here, we want to look at older adults in these areas. So we can go to data enrichment here, enrich layer. So we've got our drive time layer here selected. We can go select variables. So here I'm interested in age. So it's going to be under the age category. And here I'm going to say show all age variables just because I find it a little bit quicker to go. Then I want to go total population. So I'm going to look at 2020 and 2030. So here I'm going to select older adults, and we'll define older adults for this scenario, anything above 60. And then I can go down to 2013. And we'll pick 60 and above again. I'm going to uncheck use current map extent. Just want to see how many credits that's going to use and run that analysis. So basically that's going to take, like I mentioned last week, it's going to take census data, death rates, mortality rate, or yeah, mortality rates, and basically project 10 years down the road, or I guess 9 years, what that population will look like. This one's taking a little bit more time. that's great. Oh, what happened there? I'll try one more time. Maybe we'll just do 2020 and 2030 one at a time. Another thing so I just looked here, see if one thing that I found in the past is that if it's not a hosted feature layer, these tools won't work. Whether or not that's changed, I'm not sure. So I just went and looked, and it is a hosted feature layer, so we're good on that end. Okay, I'm not quite sure what's going on here. But basically the outcome would be you would see the population based on those age groups. And you would see that they would be increasing. And then from there, you'd be able to plan out, okay, am I having, a greater growth population in this area here? Is my kitchen big enough to accommodate for that growth? And basically you'd be able to plan out from there. So unfortunately that didn't work. So that's all I had. Any questions or comments? Quiet, crickets.